Good afternoon. For this sharing, I am Jia Xuan from China Mobile. I also have a partner to join me for this session, Mr. Lu Bing from ARM. Currently, I'm responsible for two parts. One is Kubernetes, and now I'm a member of Kubernetes. Another part is for secure computing. So today, I will focus on these parts, which is based on Kubernetes and ARM platform. What are the potentially future applications? Also, we will know the needs of edge computing and also why Kubernetes fits more for these scenarios. So before we officially start, I will make a survey among all of you. How many of you sitting here work for IoT related design and R&D? Raise your hands. Thank you. So a following up question. If you raise your hand, how many of you use ARM? Only ARM, purely ARM, or any other platforms to be integrated? So when you develop IoT, do you use ARM platform or the other platforms? So you're still on the upper end. For edge computing side, I just delivered this in 607, so I will share with you about this again. In terms of the operators, the edge computing relating to two parts. One is the network side edge computing, another is the on-site edge computing. So today we'll focus on the on-site and in terms of how to architect your cloud and what business will it shoulder and how to reduce the cost. So first of all, I will anchor the on-site great edge computing. In terms of IoT, what problems will come across in our industry? Actually, this is very clear in our sector. We cooperated with lots of enterprises. Now they're building smart city and smart buildings and also smart factories. A lot are based in the parks or campuses, and they actually don't want to enable their workflows to flow out of their parks and campuses, and we cannot control. So in terms of industrial scenarios, their protocols are ICANN or they are independent or the private protocols, not the IP protocols. So these protocols are not fitable for putting onto the cloud for management. So what should we do? How to integrate these capabilities on our industrial gateways to transfer the protocols and to connect the protocols. And we can take the IP flow. So this is a new cloud scenario, and we need to integrate all distributed machines for better administration. This is our first need. And also low latency. A lot of people will talk about the deployment of 5G. After this rollout, the latency has been reduced. But when we discuss with the industry, they have not very high requirement for latency, but very high requirement and need for the distance. How to understand this? At your home, we gave you a cable and you can enjoy the video. The traffic and speed very sound, and also you can enjoy this. But if we offer the internet service for the whole building, then sometimes the speed will be reduced. Broadband bandwidth, no problem, but the speed has problems. So which means if nobody uses it, latency would be very low. But if lots of people use it, latency would be very high. So can you comprehend this as low latency? Yes, actually it is. But in terms of industrial scenarios, what they require is to control the time within 10 milliseconds. So if you reach 11 or 12 milliseconds, your system will break down. And they do need this distance-based latency, low latency. So for the on-site devices, if you will manage them on-site, how to provide better distance based guarantee. In terms of standardization, now we're promoting the TSN networks for the corresponding low latency investigation, and also the data volume and the bandwidth. So the data volume has exceeded the bandwidth, and we have millions levels of the quantity of devices. And also the wide area network connections are not reliable and very expensive. So in your home, sometimes we will buy the small-scale setup server. Within it, we will put our own HD video. No need for run it on the operator's network to play the video. No need to occupy the bandwidth. Also, take this from the cost perspective. Assume we have deployed our services on the network side, edge computing. According to the pattern of the public cloud, you need to pay every month for connections, and you need to buy the storage every month. You need to pay a bit money, 10 yuan or 20 yuan. Not sure, but you have to pay. Or you need to pay through ITE monthly membership, or you buy a device, put it at your home to provide very stable video service for you. And now lots of people are trying this. Or you buy a USB yourself. The cost is 40, 50 yuan. Or you can purchase the other devices. So the users need to balance, because edge computing focused on the cost orientation instead of the technology. So on-site will also shoulder lots of value to serve. And also in terms of information safety, relates to personal privacy data and business data, very sensitive, and third-party apps and third-party programming designers. Now we have lots of pilots. More than 90% scenarios are private, based in campuses and parks. So China Mobile can provide us the 5G infrastructure, but the traffic will not go out of their parks. So for consumers, they're still using their own private cloud, and their traffic are not they exported. So very safe. And in lots of vertical sectors, this is their need, because in the verticals, migration to cloud is very slow. And also with the edge computing, we will come across similar problems, because edge computing will come across similar problems to the cloud computing, unavoidable, in terms of safety and security. Because for the public cloud, its security problems are different to the private. If we offer them edge, the gateway or server services, then their traffic would not be exported out of the parks, and they can be connected to the container. And this fits better for the market. And also self-made locally fits for offline operation and on-premise independent management, administration, higher reliability, because it intrinsically has this self-made attribute. We don't want to enable our gateway to go through the breakouts. So we don't want to influence maybe thousands of the IoT machines. Otherwise, edge computing would have no value. So edge computing has the self-made attributes and persistent. Lots of people might have lots of solutions. Also can be used. But if the network come across problems, because the reliability of the edge is lower than data center. Sorry, what I mean is the reliability of edge computing cannot reach the reliability of the data center. So it's lower. So when we have the lower reliability, we need to consider the on-premise management, which means I am a a kind of weak management or administration. We need to upload the data according to needs. So this is the kind of a weak connection with the cloud. Another part is hardware config. Recently, Raspberry Pi just launched the Raspberry Pi version 4. Very good product. Raspberry Pi can run ARM's container. This guy is from ARM. Now the ARM architecture is based in terms of IoT. It has the ecosystem and better than the other systems. And lots of phones they run their architecture based on ARM. Another part is machine learning big data. Maybe you have your confusions. On the edge, the data is very small, limited, but you want to use it for big data processing. But it's not like this, because in AI and big data, we have reasoning and learning. In terms of training and learning, for training specifically, we still think that it's reasonable to be put into the data center, not in edge, and not in the cloud of edge computing because of the precious resources. So what can I do? Reasoning. We have the models very ready, and we can input the models into our phone or the data center of edge computing. So if we have the video streaming, we can use a model to process it directly, and then backend we can modify the model. So in terms of edge computing, we have the AI, and also on our phone we have the identification services or the image identification relating to AI. Also here, cost is a concern. For example, of course, maybe my deep diver not very clear. Say we have a manufacturer from Hangzhou, based in Hangzhou, they work for a camera. The cost or the price is 2,000. Their camera price is 2,000. And they can provide face recognition service, which means when we collect data, we have provide identification or recognition services for your face, and the accuracy is 60 to 70% because the chip processing capability is very small within the camera. After processing, they need to migrate the traffic into the edge data processing center. This is one mode. Another mode is they only provide camera, maybe only 40, 50 yuan. And for the information capture, and they directly export the traffic into data center. In the future, with the edge computing 5G, there will be lots of traffics, maybe for free. So what they should do is to rent the edge computer VM or CPU to process the corresponding face recognition information, which means these are two options for them. So in terms of the manufacturer perspective, I want to sell out more and the price higher. But from the holistic view, the camera, will we integrate lots of the AIs on the camera? This would be dependent on the integrated cost and price of our solution. Because you buy a camera, the cost would be only 40 to 50 yuan. And if you integrate AI applications on the front end, the camera would be 2,000 yuan. But on the road, on the street, in the intersection, you need about 16 cameras. So the cost is very high. If we offer this cloud service on the remote end, maybe the cost would be reduced. Because the payment method, the charging method, now is not set yet. So we will take parallel ways. And now we need this infrastructure augmentation to improve the capability of Edge in order to expand its ecosystem. This is CNCF and edge computing. What kind of connection partnership have we forged? In lots of the open source projects, you may find the Kubernetes project. Why we have this? Because in the current Kubernetes environment, all nodes are ARM nodes. These scale very small, maybe dozens of or hundreds of. Lots of topics today will show with you that we are responsible for maybe thousands of clusters, but actually their nodes quantity very small. But on the edge, sorry, I'll skip this part, the Kubernetes architecture.
Okay.
On the edge, the devices quantity would increase. How these devices work as a Kubernetes nodes to have better management. You can see here there are lots of devices, and we will have Kubernetes controllers, etc. But actually very hard to manage, very hard to install. For IoT device, this is too large. As I mentioned before, lots of problems, including communication. So it will come across all these problems. We can go through Kubernetes to standardize these devices and to manage them all, and to manage this as the gateway to provide this to the customer. Next, my colleague Lu Bin will come to stage.
Thank you, Jiaquan. While my colleague mentions that the smart cities and other smart projects with IoT would bring us some challenges, and one of them is that through CNCF, can we manage so many IoT devices? So let's have an overall review of them. Well, actually, it is already up to the industrial standard, and we're thinking about using Kubernetes to manage all of these infrared and Bluetooth devices, for example, your Bluetooth speakers, loudspeakers, and your infrared ACs, to be all managed with IoT. Then let's look at the architecture for the Kubernetes edge. This is a very typical Kubernetes architecture, master's level architecture, and maybe in the future we can see many big changes on the master level. And this one is a very typical master's level architecture, and as Jiaquan mentioned, in the future, our IoT cloud would be all supported locally, and the current master's level architecture is not feasible for that. If you remove the cable, network cable here, then on the edge, the slave 1, 2 could not support, and it could not select or communicate and synchronize the local data. And another would be on the slave end. And there are some core progresses, 3 of them. The first is about Kubernetes, and the second is about CNI. It might be about Frandl or Kaneko, and the third would be Kube proxy, which is about service discovery, etc. So these 3 core progresses would be critical, and if you go to check their memory footprint, you would find them very high. And for the gateways for IoT, they would have very small, limited storage. So these 3 core progresses are like very thorough changes in Kubernetes, and we would remove the unnecessary service and applications. But still, in each of these progresses, the corresponding modules should still include network, service discovery, and container management, and they would all be updated respectively. For example, for CNI, the Kubeedge would upgrade it to a distributed CNI, or, as Jiaquan mentioned, here. about information security. The secure networking would be important. In Kubeedge, the network is not only distributed, but also secure with a VPN channel. And of course, we need to realize the local autonomy of this system. And in the Kube proxy and in the KubeNet, they should all realize the edge node communication, which is distributed, and also to have some selection to synchronize the data, not only on the API server on the masters. So this is the current Kubernetes architecture. For a huge IoT cloud in the future, if you include the device discovery into it, maybe the Kube master management would be probably up to millions of devices. And if you use Kubernetes to manage this IoT cloud, what challenges may we have? But this slide is about its main advantages. At present, Kubernetes, as a container orchestration, it has a general application abstraction and about the dual coupling. And then let's look at the challenges we may face. As I said, the IoT cloud would be totally different with our traditional data centers. So the first challenge would be about limited resource. And it means that the gateways compared with the server-level hardware would have limited resources, for example, a vulnerable CPU and limited storage. And the second challenge would be about the restricted network, which means in our data center, we may use Kubernetes to manage our private cloud. But in Kubeedge, the APSO may be in the machine room of China Mobile, for example, and the gateway is in your community, in your neighborhood. It might be your home routers or the exchanges in the buildings, and they should communicate with a certain Kube master, and it will be through internet, but the latency would be severe and it would be very highly costed, and it is not reliable. So it may cause a very long delay or even interruption. And then about the local autonomy, we know that in Kubernetes, each kubeslave node would have a local cache, and it would have a primary data communication. And in the IoT scenario, because Kube master is not reliable, it is likely to be interrupted at a certain time point, and at the cloud and at the edge, it could not communicate normally. So can we let each edge to discover their friend edge and to have the primary data communication then, and also to discover the primary data with the new labels and update together? This is about the local economy. And then about IoT device discovery. You know that in the Kubernetes cluster, it does not support IoT device discovery. If you use the Xiaomi device, you may know that we could evolve a lot of Xiaomi devices into the Xiaomi system. And here it is similar. We could evolve a large number of infrared, GPI, or Bluetooth devices into the gateway, and the gateway could send it as a primary data to the Kube master. And then in the China Mobile machine room's Kube master, it could have an overall management of these millions of infrared and Bluetooth devices. And then concerning Kubeedge, it is now under CNCF, an open source project. And for the time being, KubeEdge is based on Kubernetes, 100% compatible with Kubernetes API. And it has customized edge node components and runtime. So for each slave, Kubernetes and kubeproxy would be replaced with edge core. And it could be in a distributed manner. And it has a reliable messaging pathway. It means we have a PubSub for registration of these Bluetooth and infrared devices. And for our internet devices or home hardware, we do not want to lose them. So we have a more reliable pathway for them. And we also have an edge offline autonomy. It means at any time point it could be interrupted by the Kubernetes, and it could also have the real-time synchronous updating with their corresponding nodes. And we also have a very enriched application and protocol support to support all types of devices. And it also has a simplified device access. And then let's look at the overall framework for KubeEdge.
在我们的应用程序从应用程序的一个角度来看的话，
From the
我们的
applications
Kubernetes 的话，应用程
perspective,
序
for
的话是很
KubeEdge,
简单。
its application would be very simple. And on the KubeMaster, there is an edge controller. And at each slave, it adds an edge core. Memory footprint of edge core compared with the 3 core progresses on the Kubernetes slave, it is much more streamlined and could be run on the 100 MB gateway. And for the edge controller, it is on the cloud, and it could synchronize the edge nodes and the application status for service to the primary data. And it could introduce the abstract API, for example, for infrared devices or for Bluetooth loudspeakers. It could have this abstract API of the devices. And the edge core is also exclusive for this IoT system with an extra device discovery function. This is discovery of the devices. And we also introduced edge core, which means on each slave end, there is an edge core to manage the application on the edge nodes and to realize the runtime for the pod in a light way, which means it is a very lightweight Kubernetes. And then for this, which is like the core or the soul of KubeEdge, and we need to pay attention to 4 things. The first is Edge Hub, and then the Meta Manager about the metadata service, and then the HD, a mini Kubernetes, and also MQTT, the 4th one, which is for discovering devices. And for MQTT thread, we could pop all the discovered devices onto the master. And then let's look at these 4 modules one by one. The first is Kubeebus, which is like a CNI plus kubeproxy in the Kubernetes, which is like a channel for distributed routing and VPN, offering a secure network. And then for Kubeebus, it has the following important functions. First, through the VPN channel, it wants to connect all the edge nodes And for each edge node, it could at least discover another one. And the second function would be to guarantee the communication between edge node and cloud. And the third one would be about discovery of the service, which is similar to that of Kubernetes proxy. It is like the load balance. And then about the metadata service on the edge, because the edge node would be connected with the cloud through internet, which is not reliable with a very narrow bandwidth. So for metadata, it evolves the following important features. First, this service is quite long-lasting. If the connection between the edge node and the cloud is recovered, and then it could be synchronized to the edge cloud. And because of the narrow bandwidth and instability of and high cost of internet, then the synchronization is in an incremented way. It is not as what we used to have. It is to synchronize the increment in the recent time period to reduce the network flow. And the third would be about the decentralized metadata service. As we mentioned for Kubeebus, it could make sure of communication between the relative edge nodes, and if here the edge nodes could be selected by their relative edge nodes, and then it could be synchronized. And then about the discovery of the devices, for Bluetooth devices, it is okay now. So for the time being, on the ARM platform, including ARM32 and ARM64, Kubeedge is available, and you could download it and try it on the ARM platforms. And then for the Kubeedge, we still need to further some key features, like the unified management of the cloud edge, the config map, and more device recovery should be involved as well. And the roadmap is here through the link. And you can have a look at this. For each edge node, each edge core could completely simulate a slave function, and on the Kubernetes master, you can see it's 100% IPR compatible, and it is not different at all from a normal slave. And this edge core progress is very critical in the slave. Can I zoom it in so that you can see it more clearly? So at present, as an edge node, its behavior is totally same as that of a slave. On the edge node, we can even deploy an HTD symbol. In this example, we're using a notepod.
目前来说，在 ARM 上已经是都已经 ready 了。
So on ARM currently now everything is ready. For the next step, we need to introduce new features. So this is the end of my presentation and our demo. Any question? Sorry, the interpreter didn't hear the question because there's no microphone. And the answer is like, the Kubeedge is like to distribute the 3 core progresses on the Kubernetes. And as I said, the core thinking here is about the synchronization of the data, metadata by their increment. Well, is it also connected to the cloud? Yes, because I said the Kubeebus is like a CNI and a Kube proxy, and it adopts a VPN channel, and it could make sure the master-slave and slave-slave communication, and it also has a load balance and service discovery function, so as to make sure of local autonomy and the relative edge nodes could select and synchronize their metadata. You mentioned the relative edge nodes, but for the millions of devices, maybe their relative nodes would also be up to millions. Well, the million level means the Bluetooth and infrared devices in the gateway, for example, your water heater, your Bluetooth loudspeaker, and also your air conditioners at home. Actually, the million level of gateway would be less in an order of magnitude than the edge nodes. While you mentioned in one of your slides about the features of edge computing, maybe in the first slide, and it mentions about information security, and I would like to know that when you use edge computing in information security, do you have any specific use case? Well, as I said, the Kubeebus would offer VPN channel to make sure of the network security and then the security about the runtime. We now have Kata and gvisor, and Kata is ready on the ARM. And tomorrow I'm going to talk about gvisor on ARM. I have another presentation on that. While I understand that some devices may contain some sensitive data, and maybe it could run on the nodes or locally, can you use your platform to deploy the whole architecture? Yes, maybe you can make it a new feature. And in our group, you could initiate it for more discussion involving more people. It may evolve the secure data design. And have you compared EdgeX together with Gateway yet? Not yet.
We can regard HX as the fundamental operation platform. Before we discuss this with their operators, so Kubernetes can work as the coordinator on the cloud, but HX is a kind of a carrier on the edge. Sorry, I have used up my time, so I can have communication with you offline. I personally think that Kubernetes fits for this. Thank you.